Today we are going to learn about Pauling's valence bond theory. The main points of Pauling's valence bond theories are: first, the central metal ion of the coordinate complex make available a number of empty orbitals. It is these vacant orbitals that overlap with the ligands. Second, the number of orbitals made available is equal to the coordination number of the central metal ion. Third, these orbitals are made by hybridization, that is, adequate number of vacant orbitals such as S, P or D of the central metal ion hybridize to give an equal number of vacant orbitals which are directed towards the ligand's position according to the geometry of the complex, and the empty hybrid orbitals overlap with the fully filled orbitals of the ligand, forming a coordinate complex. In coordination compounds, the geometry of the complex is associated with the type of hybridization, such that the sp3 hybridization will give you tetrahedral, dsp2 will give you square planar, while sp3d2 and d2sp3 will give you a octahedral geometry. In Pauling's valence bond theory, the ligands can be classified into two types. They are strong field ligands and weak field ligands. Iodine, bromine, chlorine, fluorine, OH- etc. are weak field ligands, and carbon monoxide and NH3 etc. are strong field ligands. Now let's look how to illustrate the formation of a coordination compound according to valence bond theory. Hexafluoridocobalt, for example, that is COF6 3-. Here we need to find the oxidation state of cobalt. For that, the total oxidation state is -3. Let the oxidation state of cobalt be X, then X plus -6, that is, each of the fluorine atom has -1 as oxidation state. The total will give you -6. Therefore, oxidation state of cobalt is equal to cobalt oxidation state is +3. The outer electronic configuration of cobalt is 4s2 3d7. Therefore, cobalt +3 oxidation state will be 4s0 3d6. In hexafluoridocobaltate 3, the cobalt is in +3 oxidation state. The outer electronic configuration of cobalt 3+ is 3d6. Since F- is a weak field ligand, it is unable to pair up the unpaired electrons in 3d orbitals. You should always remember that the strong field ligands will always cause maximum pairing of electron in the outer orbital of the central metal ion, while weak field ligand do not cause electron pairing. Here we are taking F-. Since F- is a weak field ligand, it could not cause pairing of electron. No pairing of electron. So this is the outer electronic configuration of cobalt. It has 6 electrons in 3d shell, 3d orbital, and 4s, 4p, 4d orbitals are left vacant. When F6 minus ions approaches the central metal ion, each of the F minus ion will contribute a lone pair each. So total 6 lone pairs will be accommodated in the outer orbital of cobalt. So to accommodate this 6 lone pair electrons, the 1 4s, 3 4p and 2 4d orbitals hybridize and form sp3d2 hybridized orbitals. That is, these orbitals hybridize together and form sp3d2 hybrid orbitals. That is, 1s, 3p and 2d orbitals hybridize together to form sp3d2 hybrid orbitals, and each of the lone pair contributed by F minus will be accommodated like this. One pair here, one here. This is how the formation of hexafluoridocobaltate-3 occurs. The resultant complex is a high spin or paramagnetic compound since it has unpaired or electrons here, and it is a outer orbital complex with octahedral shape. Since the hybridization is sp3d2, it will be octahedral in shape, and it uses the outer d orbital. It is a outer orbital complex. Next we are going to look at example hexaamine cobalt 3 ion, that is CO NH3 6 total 3 plus. Here also the oxidation state of cobalt is +3. So the outer electronic configuration of cobalt 3 plus ion is 3d6, like this. The d orbital 1 2 3 4 5, 4s, 4p. Here also the 4s and 4p orbitals are left vacant, and in 3d orbital it has 6 electrons, 1 2 3 4 5 6. Here the approaching ligand is NH3. Since NH3 is a strong field ligand, it causes the pairing of electron in the outer orbital. That is, these electrons will get paired to the inner orbital. Now, this is the resultant electronic configuration or outer electronic configuration of the cobalt 3 plus after the pairing of the electron occurred. The pairing of the electron occurred due to the arrival of the strong field ligand NH3. Now, each of these NH3 will contribute a pair each. So, there will be total of 6 lone pairs that is to be accommodated with cobalt 3 plus. For that we need 6 hybrid orbitals. Therefore, these 2 3d orbitals and 1 4s and the rest of the 3 4p orbital hybridize together and form d2 sp3 hybrid orbitals. In this d2 sp3 hybrid orbitals, the electrons contributed by the NH3 get accommodated like this. So the resulting complex is a low spin complex because it does not have any unpaired electrons. Therefore, it is low spin or diamagnetic. And it is a inner orbital complex because it does not uses the outer d orbital, it only uses the inner d orbital for hybridization, and it is in octahedral shape. Since the hybridization is D2sp3, it will be octahedral geometrical shape.